Hi, 7th graders, Mixed there here. In this lesson 3.7, we will be using graphs to compare relationships. Here are our learning targets for this lesson. I can compare two related proportional relationships based on their graphs, and I can identify how K affects the line. We're going to start this lesson by looking at a kind of abstract graph, and I call it abstract because we will be comparing two situations where there is no numeric data. And what I mean by that is down on our X and Y scale, we don't have like a 1, 2, 3, 4. There are no numbers for us to work with. But we can still tell a lot of information about a graph like this. So what we're looking at here is we have the meteoroid Perseid 245 and an unknown asteroid, which we will be calling asteroid X, and they are traveling through the solar system. We have here our X and Y axes. Our x-axis represents our time in seconds, and our y-axis is representing our distance in kilometers. I want you to pause this and just stare at this graph for a little bit and think about the question, which of these are traveling faster, and how can we tell even if there is no numeric data? So if while you had this paused, you were staring at this and thinking that asteroid X looks like it is traveling faster, you would be right. And there are a few things we can do to justify this idea. So what we have here are two copies of that same graph we were just looking at, where we're comparing asteroid X to the Perseid 245. And what I have added here, let's look at example A right here, is we have what I'm going to call just a line of comparison, and this one is vertical. And what this vertical comparison will show us is the distance that each of these space rocks was able to travel at the same amount of time. Now, even though we don't have any numeric data, this point right here, and I'm just going to call it a random X, could be any unit of time. That could mean 1 second, that could mean 100 years. But it still shows us that in that same quantity of time, we know that our distance as it moves up is constantly growing. So we can follow from this time point and be like, well, in the same amount of time, the Perseid 245 was only able to go that far, and asteroid X was able to go that far. And we don't necessarily know what that distance is. All we know is that it is a greater distance. And we could do the same concept with a horizontal comparison. So over here on example B, I have this horizontal comparison. And what that is showing us is how much time it took each of our space rocks to travel the same distance. So again, we don't really know what that distance is. We just know, we'll just call it distance y. We just know that on our x-axis time, as it moves forward, it gets greater and greater in value. Therefore, if for this distance y, if this were a race, our asteroid X would be the first to hit that distance y. And it would take more than double the amount of time for the Perseid 245 to reach that same distance. That are two ways that we can justify that asteroid X is traveling faster. Let's see how this plays out when we are comparing graphs where we do have some numeric data. So we have a word problem over here. We have Lynn and Andre. They are biking home together from school at a steady pace. And again, that idea of a steady pace signifies that this will be a proportional relationship. So we have Lynn biking 1.5 kilometers, and it took her 5 minutes. So I always highlight any number because that is what we will be working with. And it took Andre, was able to bike 2 kilometers in 8 minutes. So what we have there are a couple of rates. And since we see on our graph here that time is x, right there, and distance is y right there. I'm going to go ahead and make some coordinate pairs for Lynn and Andre. So Lynn's x, or Lynn's time, is 5 minutes. So I'm going to put a 5 for her x. And Lynn's y, or Lynn's distance, is 1.5 kilometers. So her y is going to be 1.5. And I can go ahead and plot that exactly how it is. So I'm going to find where my x is 5 and my y is 1.5, and I'm going to put a point there. I'm going to do the same thing for Andre now. And we know that his x is 8 because 8 minutes, and x is time, and his y is 2. So I'm going to plot a point there. So I find where my x is 8, go up to 2, and there we have it. Now what I want you to do is pause and think about how you can use this information. Let me tidy this up a bit, but you also have it on your notes. How you can use this information to also find the K of each of these situations and put a few more points on these graphs so that you can draw the lines and compare them. Go ahead and pause and fill out the graphs on your note sheet. So here's what I got for calculating K's. I took my Y's, which were my kilometer, and divided them by my X's, which are my minutes. And I found that Lynn had a K of 0.3, and Andre had a K of 1/4, or for those of you who prefer decimals, 0.25. So what I can do is go ahead and plot those points. So I know that at that, where my X equals 1, my Y will equal K. So there's Andre's point. And for Lynn, again, where my X equals 1, that means my Y is going to be 0.3. So it looks like Lynn's point is just above Andre's, and then you can use those points to go ahead and put some lines in. And remember to connect them all to the origin, or 0, 0. And what we can see once we have those lines pointed is even though Lynn's K was just ever so slightly more than Andre's K, that greater value of K, or that greater constant proportionality, led to quite a steeper line as it moved forward. So congratulations, Lynn, you're faster. The two most important ideas I hope you come away with from this lesson is that a steeper graph is going to have a larger constant proportionality, or a larger value of K. And if we are working with a distance versus time graph like we were in both of these cases, a steeper graph is going to also show a greater speed. All right, go ahead and work on those journal problems, and good luck.